Hello, good evening everyone. How are you? Feeling sleepy after lunch? Well, I hope I'll keep you awake. All right? So in this talk I'm going to talk about artificial intelligence and its applications in medical diagnosis. I'm going to start with a video about artificial intelligence, just a quick look of the latest research in the artificial intelligence domain. Enjoy the video.
It's a passion for discovery that unveiled the genesis of all that exists in the universe. Today, the power of AI helps computers achieve superhuman capabilities in image recognition and lets scientists save our most precious resources by analyzing in 1 moment what used to take 10 years. Everyday devices translate even the most complex languages from voice into text and images into words.
Xavier is now present.
Helping the visually impaired recognize an old friend, or letting a blind woman read to her child for the first time. Autonomous vehicles give us the freedom to reimagine our city streets and travel where there are no streets at all to help the lost find their way home. We see robots teach themselves to perform simple tasks. We even watch in awe as they take their first steps. And today, a 2,500-year-old game meets its match as a computer competes with one of the greatest human champions of all time and wins.
Great, thank you very much. So this was a quick peek into the latest research of AI. And now let's go back to the theoretical parts. And let me talk a little bit about what AI means, and then talk about some AI algorithms, and then I'm going to talk about the advances in medicine related to AI. If you have any questions, please save them for the end. I reserve plenty of time for us to have a discussion at the end. So first, what is artificial intelligence? So just speaking between us, it's human-like intelligence that computers exhibit. More theoretically, in computer science, is the study of intelligent agents. And what does that mean?
And so there is the environment, and we are building an agent. The agent is going to interact with the environment. The agent is the AI. Okay? How does the agent interact with the environment? Is through sensors. So the agent has various sensors, and you can think of sensors as video camera, microphones, various motion sensors. Even a keyboard can be a sensor. So the agent takes input from the environment through these sensors. That's how the program reads its input. The agent produces output, interacts with the environment through actuators. And actuators is anything that the computer can actuate. You can think of it as mechanical actuators, or the display can be an actuator, or the elevator doors closing being an actuator. So the agent reads these sensors and actuates, provides output to the environment through the actuators. And the key part of this agent is the decision function. So we build numerous sensors, we can build numerous actuators, but we need a really powerful decision function. And that's the core of the AI. This program by itself, given the values of these sensors, is going to make a decision and actuate, provide input to the actuators in a certain manner. Okay? So that's the basic of AI. You have this agent, interacts with the environment through sensors, and actuates, produces some signals to the actuators. Okay? So now people define artificial intelligence, classify it in 4 types. And I'm going to quickly go over them. So the first type, the simplest most, is called purely reactive. Okay? The agent doesn't know a lot about the environment. It can usually solve a simple problem. Think of it as a game of chess. You tell the robot where the pieces are, and it's going to tell you the next move. So it's very simple. The robot doesn't have any memory. He doesn't know he actually played with you last week and you beat him. He doesn't remember things like that. But he knows, given all the pieces on the board, this is what I need to move now to win. So it takes a decision at one point and moves on. A second class of agents have a limited type of memory. So they remember something that happened in the past, not a lot, but something and enough so they can make a decision. Think of it as a self-driving car. So you have a program controlling a car, and the program has all these sensors, makes decisions about the environment at any point, but also remembers what happened in the last minute or so. So he kind of remembers, yeah, there was a car behind me. I don't see it right now. Maybe it's in my dead spot, but it should be there. So it has a little memory. The third type is this theory of mind type, where agents start to understand thoughts and emotions. Okay? They look like humans now. This type of AI doesn't exist right now. Hasn't been built, but you have seen it in movies, in Star Wars or iRobot, so movies like that. You've seen this type of agents that have and understand emotions. And finally, the last type, the most complex type, is a robot that is self-aware of itself. So he actually can predict your feelings. He understands your feelings and he can predict them. He would know you get mad on him if he does that. Okay, so this is the most advanced one. It hasn't been built as well. It has been shown in the movies, though. So these four types of artificial intelligence, going from simple to more complex. Right now, we're sitting in the first two types. So let's talk about a little bit of history of how artificial intelligence came to be and how it evolved, especially in computer science field, because that's where it exists most of the time. Artificial intelligence started in the 1950s, and the programs were very hard to build at that time. So they were very specific, solving games usually. So they teach the programs how to play chess or play various games. And the way they were programmed is you tell the program all the rules and what to do at every single step. You tell him what are the rules of chess and how to move, what to do at every step. Okay? So there was a lot of programming involved, and they were very complicated to write. That's why they weren't very complex at that time. So they were just simple games, it's very clear rules, because you needed to write them in the program. Later, around 1980s, there was this machine learning evolution in artificial intelligence. Instead of having you write all the rules for the computer, how about the computer learns some of the rules himself? So you give him some examples. Look, this is bad, this is good. Look at these things, and the computer learns these rules by himself. And this is called machine learning. And let's talk a little bit more about this type, and then we're going to go to the next one as well. But first, machine learning. So how does it work? How we can write a program where the computer learns some of the parts? And I'm going to walk you through an example. And let's suppose we want to have a computer that we show him a house, and he can tell us if the house is in San Francisco or is in New York. So how we can have the computer learn this type of program without giving him explicit rules, without telling him if the house is green and round, it's going to be in San Francisco. If it's orange and square, it's going to be in New York. So without giving the explicit rules, how about the computer learning them? For us to happen, we need to have some intuition. We need to tell the computer what kind of things to look for. And let's think about it. So we're trying to distinguish houses between San Francisco and New York. And let's take an overview picture of the city. So one thing you would notice, New York is very flat. It's most of the sea level, and there is no hills or anything. San Francisco, on the other hand, is very hilly. There is a lot of hills. So how about we look at the elevation of the house? So we suppose we have all these houses. In this graph, each line represents a house, and the vertical axis is the elevation of the house. So this is sea level, and the higher we go is going to be elevation of that house. The green houses are in San Francisco, the blue ones are in New York. So now you could see, let's say if we say that the elevation is more than 240 feet, there are no more houses in New York over this elevation. So all of them must be in San Francisco. So that's one kind of rule that the computer will learn. We tell him, look at the elevation, and he's going to come up with these rules. He's going to say, oh, if it's over 240 feet, which is about 70 meters, it's going to be in San Francisco for sure. Okay, so that's one type. Now, what about if it's below 70 meters? Well, it's a mix, so we don't know yet. And elevation is not enough. So we need to look at something else. What else can we look at? Say we look at the price of the house. This is another graph showing the price. The price is on the x-axis, so this is the cheapest, this is the most expensive. and the elevation is the vertical axis. So green dots, San Francisco, you see not so expensive, a lot of variation in elevation. New York, a lot of variation in price, pretty much the low level. So that's two things now, okay? So how would the program divide this space? So first we said if it's over 70 meters, it has to be in San Francisco. So that's this chunk here, okay, it's clear. Now this chunk, which we don't know, we say if it's over 19,000 feet per square meters, it's in New York. So this is the part that's in New York. Now we still don't know about this white part here. We still have to continue adding rules to it. But so far we look at elevation and we look at price. Computer is going to build these rules now. So other things he's going to look, we can tell him, well, look at the total price, look at the size, look at the number of bedrooms, number of bathrooms, what year was this built. And using all these features, the computer is going to build a decision tree. This is one type of machine algorithm, and it's called decision tree. You probably use this many times in your mind or even at school. It's basically you make a decision based on some conditions. Say, I give you a job, you decide whether to accept it or not, you apply these rules. Is this salary this much? No. Okay, I decline. Is it further than 1 hour from my home? No, I accept. Do you give me free coffee? Yes. Okay, I'll take your job. Okay. So this is a decision tree. We call it decision tree because it looks like a tree. It's an upside-down tree. Okay? So this is one type of algorithm. So going back to our problem with houses, the computer, we give him all these features. We tell him, look at elevation, look at price, look at number of bathrooms, number of bedrooms, and he's going to build this tree. At the top here is the root node, and it's going to say elevation. Okay? It's going to look at the elevation of all the houses. You see the blue bars and the green bars. These are the houses in New York and San Francisco. It's going to pick a value here. It's going to say, if you are below this value, go to the left. If now, go to the right. Now, on the left, let's look at something else. Price per square feet. Go to the left, go to the right, and keep going. Finally, at the end, everybody is going to be in the same class. So there are going to be only houses from San Francisco or only houses from New York. The size of this circle here is how many houses ended up in that branch. So now, let's say we show a new house. So the computer learns this tree. He has this in memory, all these rules. We didn't tell him any rules. We just tell him to look for these clues. Now he has this in memory, a new house. We show him a new house he has never seen. So he's going to first check elevation. Which one is it, left or right? He's going to go, let's say, on right. Now he's going to check the price. Which one, left or right? He's going to go on one side and keep going. Finally reaches the end. OK, what is the label here? Oh, we said San Francisco. Then this new one I have never seen. It must be in San Francisco. So this is how machine learning works. Okay? The computer learns these trees, learns these rules, and now he's going to apply them on data that he has never seen. Now, is decision tree the best algorithm? Not really, and there are many others. And the algorithm you choose depends on what your data is like, and you need to look at your data. So here is one example of one data set. We want to distinguish between red points and blue points, and we look at two axes. It doesn't matter what they are, X and Y. You see the points here, they form some kind of shape. So different algorithms will try to divide this space so they can label a new point. If I give them a new point, they're going to tell me if it's red or blue. And this is how they divide. Our decision trees, they are here. Okay? The decision tree, remembers, always splits the data in two and keeps splitting it until it reaches the end. So you see these square parts here. Okay? So any node that falls in the blue area, the computer is going to say is blue. Any node in the red is going to say is red. Obviously, it's going to have some errors. So this number here, 0.95, is the error rate of this algorithm for this data set. And other algorithms will have other precision. So you see some do good, some not do so good. What they try to model is to split your space so they separate your points. If the data looks different, the algorithm will perform differently. So all of them, they try to understand what kind of shape here. So for example, here, the blue is in the center, the red is on the outside. So they try to model this, okay? And the algorithm could model this better or poorer depending on the algorithm. So the key here to understand is that there are many algorithms to do machine learning, and the one you choose depends on what your data is. All right. Very good. So we learned a little bit about machine learning. So machine learning was between 1980s to 2010, was very hot, and everybody was doing. One example here is the spam. The spam filters use machine learning. You just show the computer emails that are good or bad, and he's going to learn them. Now, lately, there is a branch of machine learning, a more advancement in machine learning is called deep learning. And let's have a look at this. Let's have a quick look at this type of technique. Interestingly enough, this basic idea inside this technique is coming from medicine. It's coming from neurobiology. And here you probably recognize this. You have these dendrites that take input, and there are signals produced through the axons. Okay? So the computer scientists model this type of system in what is called perceptron. Perceptron will have multiple inputs. There will be a function here and produces one output. Okay? Now, the same way in our brain we have millions of these, computer scientists build artificial neural networks composing of millions of perceptrons. And here is one example. This is the basic one. You take two inputs, produce one output, two or more. Okay? Two or more inputs, produce one output. Apply a function on it. Here is a more complex one. You have two or more inputs. You have some middle layer. Okay? There are some function and computation happening in the green dots. And then finally a red layer. So this more complex one. This inner layer is usually also called the deep layer. Okay? That's why the name comes, deep learning. And then you can come up with more complex ones, okay? And even more complex. So you end up building all these complicated structures where you have some yellow inputs and produce some red outputs. And there are some nodes in the middle that can go back and forth and do some computations between themselves. This is the basic idea of these neural networks and deep learning. And here is one example of how facial recognition happens. It's done through deep learning. And here would be the layers. So the first layer in facial recognition would be to detect the pixels. It's going to look at each pixel in your picture. They usually use grayscale pictures, so not necessarily color. And they're just going to say if it's light or dark. This is the first layer. The second layer, using the information of the first layer, is going to detect shapes, simple shapes, like lines, squares, corners, all these things. Third layer is going to start using the information from the second layer, and it's going to detect eyes and nose and mouth, so simple facial features. Finally, the fourth layer is going to actually put everything together and detect faces. So here's how this works. So you have these layers that I was showing you, these green layers in the middle that compute all this information, and finally you have the output. This is the face in the picture. All right, so that's a quick introduction into artificial intelligence. And I showed you this evolution, how it evolved from writing rules to having the computer starting to learn, and to deep learning, where the computers actually don't need any rules anymore, but need a lot of data. So there is a lot of data that is needed, and these networks that are built are humongous. So now let's go back to medicine. So let's talk in the last few minutes about diagnosis in medicine, and how machine learning and maybe deep learning in particular can be used to do diagnosis in medicine. And I'm going to show you two very recent studies published in some very reputable journals about using machine learning to do diagnosis. And the first one is on breast cancer diagnosis. So some of you might be familiar with this. So there is a biomarker being extracted from the patient, and then that is visually analyzed. What they're looking for is for dark spots like this. This is a more not very advanced one. This is a more advanced spot. So they're going to look for these mutations. So it turns out that the humans actually have some error rate. When doctors look at this, maybe in the United States especially, 80% of the positive cases that they say are positive are actually false. They are not positive. The patient is fine. And the 4% of the negative cases where they say the patient is fine is actually a misdiagnosed. The patient is actually sick and should be treated. So how can the computer do this? So here is very similar to the face extraction that we looked at. The computer can look at the image that you have, okay, this biomarker image. He's going to do some computation on itself, this kind of similar to the layers. He's going to do some image processing. Then he's going to do detection of the cells. And finally, he's going to label the cells. And he's going to classify the cells among these 6 levels here. And depending on which level, the cell is affected or not by the tumor. Okay? So how did the computer did? So in this study, the researchers looked at 71 cases. And they had initial diagnosis from a pathologist. Okay? He made that analysis, and then had the computer make the same analysis. And what you see here, blue is negative, so no disease. Orange is positive, and white is I cannot tell. And you can see they agreed on 59 of the 71 cases. The two agreed, the doctor and the computer. In 12, they didn't agree. So what the researcher did, they had an independent review, so they had a third review, look at some of the cases, and especially the ones where they disagreed, and the independent review actually agreed with the computer more than with the initial doctor assessment. So one conclusion you can say is the computer actually did better than the medic in this case. Okay? Computer learned these images, look at them, and the computer won't do human mistakes in a way. Let's look at another study. This is about skin cancer diagnosis. You might know it's the most common human malignancy, the skin cancer, and the most popular, one that you might have heard of is the melanoma, which the point with it is not very popular, it's not very spread, at least in US. These are statistics from US. Only 5% of the skin cancer are melanoma. The problem is it's very deadly. 70% of the deaths coming from skin cancer are from melanoma. And the survival rate for 5 years, if you detect it earlier, is going to be 99% if you detect it early. So it's very important you detect it early. So talking about skin lesions, there are different categories. There are really bad ones and not so bad ones. And normally, dermatologists look at the skin. So the diagnosis is done visually. And they look at the skin, and in US at least, they have this criteria, A, B, C, D, E, where they look for asymmetrical, B for borders, and so on. So the doctor does this diagnosis. Now, here is what the researchers did in this case. So they had almost 130,000 examples fed into a machine learning algorithm. So they had these examples. For each example, they had a label. This is what the disease was. They fed into the machine learning. The computer learned all these examples, bad, good, bad, good. And then they had new images. They show it to the computer. They show it to the doctor, and both of them made a diagnosis. For the computer to help it, they built this hierarchy of diseases. So you have the skin disease in the middle, and then the 3 branches, and then each of the 3 had sub-branches. The green ones are the important ones. This is what the computer was told. So for each image, the computer was told one of these green labels. And this is what the computer was predicting, the green label. Now, if you know the green labels, you can infer the red labels, so you can now know if it's bad or not so bad. It turns out the doctors had a 66% accuracy on analyzing the picture. So the doctors look at the pictures as well, label the diseases. The computer looked and labeled. The computer did better than the doctor. The computer had a 72% accuracy. The researchers went even further. They looked at biopsy results, and they had similar results. What's very, very interesting about this research is because it's a skin, you don't need to extract anything from the body. You can implement this as a phone app. So imagine taking your phone out of your pocket, you take a picture of your skin, the app will tell you, yeah, you might have cancer or you are fine, don't worry about it. Okay? So this is a very, very interesting application that could appear in the next year or so. This is a very recent study. All right, so let's spend a few slides here. Let's talk about some consequences of all of this. So you've seen all of this evolution in artificial intelligence, all this implication in medicine. How it's going to affect us over the next few years? Is the computer going to replace the doctors? You might think about it. My opinion is no. It's categorically no. I think the computer will not replace the doctors, will not replace the human, but the computer will augment. A computer will offer additional expertise and offer assistance to the human. Okay? I think the doctors will interact more and more with the computers in the future. And the key to this is, think about AI and humans. What is the difference? The AI knows that, meaning knows the facts, and knows how. Okay? So he knows the facts, knows how to apply the facts to make a diagnosis. Now, us humans, we know the facts as well, know that, know how, and we also know why. Okay? So we care about why is this patient sick. Okay? So I see these facts, I make a diagnosis, and then I actually wonder, why did he get the disease? The computer won't wonder why, at least for now. Okay? So I think this is a very critical advantage that us humans have over the computer. And I think this is why the humans are not going to be removed from this medical diagnosis. Now, there are some consequences we need to be careful about, okay? And one of the critical one is reducing the skills. So over short term, you might over-rely on the computer. You don't want that, okay? You want to use the computer. You might trust it or not trust it, but you don't want to over-rely on the computer. And on the long term, de-skilling, which means you get trained less and less because you don't need it anymore. The computer knows more than you. He does better than you. Why would you need all these skills? Well, you need them, and you should keep trying to get them, okay? Because if the technology fails, there are critical, very serious disruption. And also, you don't want to lose your self-confidence. You want to look at the patient and say, yes, you have disease A, and I'm pretty sure about it. You don't want to say, oh, I don't know, let me ask the computer, okay? You want to have your confidence. And you want the universities to train you as well as they do right now. You don't want the university to train you less because, well, there is a computer, it does better than you. No, you still want to have your skills. You do not want to become simple technicians. You don't want to become simple operators of the computer. Oh, let me just put it in. Yeah, it says red. Well, you want to be a doctor, okay? So the key here is as machine learns more, we humans tend to learn less. You want to stop that. You want to avoid that. You want to keep learning your things, keep improving your skills. On the other side, about patients, well, if the computer does so well, the patient might not come to the doctor anymore. Say, well, I scan myself with the phone or whatever, I check the internet, why do I need to come to the doctor? Well, he needs to come to the doctor because there are many things the computer will miss. And on the other side, the patient might worry. Think about a patient that every 5 minutes he keeps scanning his skin, hoping he gets better, or being worried he might get worse. Okay, so you don't want the patients to worry needlessly. And patients might miss the human interaction. Patients like to talk to a person. They don't like a computer telling them, yeah, you're sick. They like a human telling them, yeah, I'm so sorry, you might get better, but right now you are sick. So AI has its own problems as well. If the context is difficult, if you have a very difficult medical complex, the AI cannot take that as input. It cannot be represented. This complex context cannot be represented in the computer right now. Medical data has a data accuracy and completeness problem, okay? It's not very accurate, it's not necessarily complete all the time, and you know that. Two doctors could give the same patient different diagnoses, and none of them might be wrong. So this inaccuracy and completeness, the computer doesn't do well with that. The computer right now has a black box, especially the deep learning ones where they have all these hidden layers. We don't really know what it does inside all these hidden layers. So if it does something wrong, we don't really know how to fix it, and that's a problem. The computer science community needs to fix it. And there is a legal liability. Let's say the computer says you are not sick, when in fact you are sick. Now who's to blame? Who's to sue, okay? All right, so that's my talk here. So I talked about some introduction into artificial intelligence. We look about how machine learning algorithms work, and then some applications in medicine. Now, any questions? Yes, actually, yes. I've seen some studies on that as well. I haven't seen any recent studies, but yes, there are applications where you put the symptoms in the application and the computer is going to query a database and it's going to can give you some diagnosis as well, yes. Any other question?
Който иска просто, if anybody wants to ask a question, just tell me to give you the microphone so everybody can hear you.
Hello, when are we going to have this technology in our lives?
So some of them you might have it in one form or another. The two research studies I showed are very recent, I think from this year and last year. So they are continuing. The researchers, from what I read, are continuing and maybe starting companies or collaborating with companies to build applications. Normally, there is also approval by the government, so the government needs to review this and say, yes, this is safe for us to use in our country. So there are going to be some steps, and it might take a while, but I think the results are very promising, and it could be in the next 5 or 10 years. And you would see it at different levels. So you might see some initial ones earlier, some later. But yeah, it's going to be very exciting times, I think.
Last chance, if anyone has a question. I assure you, oh, thank you. Why me? I want me, I'm beautiful. Can you raise a hand again? Okay. Rarez is not eating people. I checked that.
So in the beginning, you said that there are 4 types of artificial intelligence. And recently, I found on Facebook a company. I don't know if I can name the company now. Can I name it or not? Hansen Robotics Limited. And they present a robot named Sophia, which they said understands emotion and feelings and so on. Is this the 3rd type or it's not?
It could be very well be. So there is a lot of research that I might not be aware of. There are many companies. Because the field is so hot, there are many companies, and sometimes the companies might claim they do something when they don't really do it yet. Or they might think they are very close to doing it, and they might start advertising. It's to be seen, okay? And plus, sometimes it could be marketing very well. But it could be very well exist, okay? Or it might appear in the future. It's not that I know of it right now.
What's the biggest difficulty? I mean, why can't we make a 3rd type of artificial intelligence? What's the biggest problem?
Well, I think right now we are working on the 2nd type. So think about self-driving cars. We're still developing that. So it will be the 3rd type will be a next step from there. But let's finish the 1st one in a way. We have some challenges there that we need to address. Okay. And I think one of the biggest ones, some challenges might not be technological. Some challenges might be of other nature, legal, for example. Right? If a robot drives a car, what happens now? Okay, let's say there is a kid on the street, the car is going fast, the robot can analyze, I can brake the car, but I might kill the passenger, or I might injure the kid. Now, who I'm going to save? This is a very difficult question. And we are going through this as a society, and there are, maybe the government is looking into it, the companies are looking into it, to make a good decision, okay? So there are various aspects. There are technological and non-technological ones, and it's evolving. There are many challenges in the 2nd one as well, before we get to the 3rd one, though.
Will AI replace the general practitioners or the specialist, or will it change medicine in some other kind of way?
I think some will be changed. Some jobs might be replaced. So I was talking about doctors. I don't think doctors will be replaced, but some maybe low-level technicians might be replaced, because think about right now. I mean, you go to the metro, no one will sell you a ticket, you buy it from the machine, okay? So there is already a person being replaced there. So it will happen as a society, some jobs will be replaced, but this will give us humans the opportunity to get other jobs which are more interesting and more productive. And this happened through the society. I mean, jobs got replaced and robots replaced jobs, and we're doing just fine now. So it will keep happening. We just need to find other jobs for us to do, more advanced ones.